Yeah, hello everyone. So welcome to the next session, that is Devops. So where we'll be discussing about the role of DevOps in service virtualization. So to start with, first we will discuss what the DevOps is. So DevOps is made up of two words like development and operation. So you all are aware that within a project there are two teams, development and operation. Within that there are many smaller teams also, right? So how we will start is like we will discuss first about the traditional model, from where that issue comes in. So in case of traditional approach, so like we have the waterfall model. So in case we have the development team and operations team. So development team first starts the product development, prioritize the few tasks, and then start with the coding phase and all those things, right? So once they are done with this, the code is deployed in the lower environment or test environment. It is handed over to the operations team for testing and validation. But the issue here is the time while the operations team is working on validation and all those things, dev team has to wait for the feedback, and they might need to work on any bugs which are reported by the operations team. So there is quite a lot time gap, and also the communication lag also, due to which the timeline of the project is extended a lot. So as a result, the cost is also impacted. Sometimes what happens is dev team has to jump to another project, right? Because they can't sit idle for such a long time, because that will impact the productivity also. So how this issue was resolved is, this problem was resolved is, so the main issue here is there is no collaboration between development team and operations team, right? So in case of DevOps, that was the collaboration came into picture. So you can see here the development and operations team have quite a good collaboration here. So so in this case, development team is aware about what is happening at the operations team, and operations team is aware about everything about the development team. But this whole collaboration happens in a DevOps approach. So that is a type of culture, it is an approach. There are many tools available, how this works, and we will discuss shortly. We will discuss about the proper process and diagram of the DevOps, how it works, right? So it helps to deliver the product in a particular timeline which is defined, right? So the main problem solved here is the wall of confusion between the development and the operation team is broken here, right? And so in case of DevOps, it's a streamlined process followed between the dev and the operations team to deliver the product quickly, right? Because what our customer expects? The customer expects like the stakeholder should have the clear picture of what's going on at the backend, right? They should know the iterations which are going in the project, what are the current status of the functionalities which they have showcased, what they want to be implemented. So moving on to our next part, that is DevOps approach. So in DevOps, we will discuss about the diagram here. So if you can see here is DevOps is represented by infinite, like, so this infinite symbol, what is defines it? So this process within a project is continuous. We also call it as continuous integration and continuous development. So there are different it is implemented in several phases with the help of several tools. So it starts with the planning phase. So in planning phase, few requirements are prioritized, right, which the development team work on. So once these are done, so they start with they start with the coding of that particular project, whether it's a website, whether it's anything else, right? And after that, the code is made, executable code is then it's moves to the build phase. So in after build phase, it is deployed to a lower environment, so test environment. So here's when it is deployed test environment, so operations team also come into picture here, because they will start with the validation and all those things, right? And then it goes to the release cycle, and finally it is deployed. So there are multiple different tools which are used here. So in case of planning phase, there are different tools which are used. We are following the agile methodology also, right? And in coding, different modules are distributed between the team members, so they have their own version of codes. And in this case, Git, which is most popular tool which is used for versioning of your code. And once the everything is in place, so that code is merged and that executable code is then built, and then it goes to build phase and further the testing phase. So you will note later on, this test phase is quite important for SV, where the SV plays a very important role in the testing phase, right? And in case of monitor, it will monitor the product which is deployed, whether in the production environment or working environment, right? So in this case, accordingly, when we will get back the feedback and other requirements which are given by the client, those are again fetched to the planning phase. So that's how it continues, and this is continuous development and continuous integration, right? So we learn much more. It will much more clear in the further lecture, where we will discuss the role of SV in DevOps, right? So please don't miss the coming up lecture, because it's quite important, because here we are discussing everything about SV. We will get to know how it fits into the business model, how it helps the customers, right? So how it is in demand, right? So now we will be moving forward the most important topic. So we will be discussing the role of service virtualization in DevOps. So how service virtualization plays an important role in DevOps, and so what all criteria do SV fit in the DevOps. So let's start. So these are the, one more thing here is, so we have already discussed the DevOps model and DevOps approach, right? So we have the most important 4 phase there, that is the testing phase. So apart from development, the most important thing is testing in a software development life cycle, because testing, different types of testing is there. So testing validates the product, how it will work in the production, and that's very important, because if a product is delivered without any testing, or without proper testing, then it will increase the cost a lot, because the product needs again sent to the development team, right? And in that case, it impacts the client reputation as well, right? Client and the customer and the organization reputation as well, right? So we will discuss here what are the challenges in the test phase, and then going forward how the SV improves that or removes them, right? So first one is the system constraint. So system constraint here is, so most of the team experience delays because of unavailable dependent system. So in a particular project or web application, there are multiple backend systems which are interacting with each other. Like we have the front end, suppose our internet banking application, then we have the middleware in between. Now the thing is, we have microservice architecture being used almost everywhere. So in case of microservice architecture, every functionality is implemented as an API, right? Every functionality, even the minute functionality, is independent of other functionality, right? So these APIs, if any one of them is unavailable, may either due to a third-party system or due to the development is still not completed, then that impacts the testing a lot, because the team can't proceed with the testing, because that component itself is not available, right? So that's what the system constraints here are. So the next one is parallel development and testing. So that is a quite important thing in the DevOps approach, the parallel development and testing, because that is a continuous process, right? So the critical dependencies are unavailable when the development and the testing team need to work on them in parallel, as we discussed earlier. so the dependencies are unavailable. That's why both team can't work parallelly on it. And the most important parameter here is third party applications. So the third party application, like we have the payment gateway, payment system, right? So we can't use that, especially for the testing purpose and for the performance testing. We can't use the third party API, because those are not either you need to set up a whole environment like production, that is very costly, right? And but in case of service virtualization, the environment setup is not that costly, so there is quite a cost reduction there. So third parties are implemented in the service virtualization, right? So that replaces the dependent third party APIs. Like we have the payment gateway, as I discussed, right? So we have the payment gateway. So suppose there are n number of test cases that need to test, and also there are in the third party API we have n number of test cases, and we have also the negative test cases. So those can be tested only by the SV, where we have to replace the original component with the virtualized one. But the thing is, front end won't be aware of where is this response is coming from, right? Yeah, middleware might be aware about that, right? So next we will discuss about the what's the role of so as you can see in this picture, so it highly improves the quality and the speed, right? So who is happy about the speed of the product being delivered? Customer, client, right? And also the quality. So how it improves the quality is because we can test more quickly, and most of the testing can be completed end to end, because all the dependent system can be replaced by the service virtualization, right? And also the other middleware systems which are not available, those can also be. Even the thing is, even you can an enterprise system, or whether it's a MQ system, whether it's a mainframe system, anything can be virtualized in. In service virtualization we can virtualize anything, but the thing is, few tools can implement those, which are the paid one. Yeah, that are quite like cost is quite high there, but still setting up the environment, completely new environment, it reduces the cost a lot if we compare it with the actual production like environment for testing. And as we discussed, it allows positive as well as negative test. So negative testing is quite important. How the system will behave in case of negative scenarios, right? Those we need to record all the behavior of the particular application. And the next thing is that speeds up the release cycle. So how it will speed up the release cycle? Because since we practice our test quickly and also completely end to end, so for sure that will speed up the release cycle, and we can deliver the product within the timeline. And so similarly we have the quick builds there. So so quickly the other functionalities are implemented, and executable code is sent to the build phase, right? And parallel testing also, which we have discussed earlier. So what it decreases the risk and the cost. So risk is the most important factor, because by early left shifting of performance and functional testing. So the risk here is, suppose we deliver a product and during testing, if the testing is delayed, and later on we came to know, like in the case of performance or functional, there are too many bugs and development team is waiting, so what's happening, and they need to if they are waiting for the testing to be completed, mostly because some of the APIs are not available, or some of there are third party APIs. So that reduces the risk. How? Because it very early it shifts to the testing part, right? Because everything is available, everything is the things which are not available are already virtualized, so we have the complete environment for testing, right? And in case of cost reduction, so the environment setup cost is quite low here, because setting up the environment like the production is because you need a proper hardware, and there should be a proper latency, right? But in case of service virtualization, environment setup is not that difficult and also not much costly, because you just need to set up the particular tool. That's for sure. You need the hardware there also, but the hardware requirement is quite less there. Also, there are many cloud models are available where you can directly utilize the service without even setting up the environment. So everything in the cloud is available, or every hardware is available, and you don't need to set up anything like any server or any hardware. You just need to install your tool and start using it, whether it is service the ready API, or whether it's wiremock, whether it's blaze meter, whether it's CLISA, anything. You just need the hardware which can be implemented in cloud or maybe a SaaS model. So next is it eliminate the third party system code. So the if even if you will so if you see here the third party applications, they most of them charge according to the transactions received, so per transaction basis. So you can imagine how much costly it is to test with the real third party APIs. Because in case of testing, you have many scenarios which are failed. You need to test again and again. Might be there is a downtime or other things. So even if there is a third party system downtime, then it will extend. Then the team can might need to sit idle, and there is no no test case can go, end to end testing cannot be done, right? So in case of third party, when we replace it with SV, there is no such thing. You can mimic the response, whatever it need to be sent. You can do anything as the production environment. So I think so you all are clear about the role of service virtualization. So that's how it impacts in the DevOps process. So end-to-end delivery, it impacts that a lot. So that's why this technology is quite in demand and it's increasing. So from 2016 till now, it has increased by a CAGR of around 21%. And there are quite a lot of things being added here as well. So you can virtualize as many as things. More and more protocols are being added now by different enterprise these models and enterprise tools.